Hi, my name is Lisa. Today we're going to talk about unicorns. Uh-oh.
Hey, this is Paul Sinenko, and today we're actually talking about tables. Not these tables, but table variables and table properties. Basically, everything that drives the logic within DGLux. We'll explore how to add rows, remove rows, calculate rows, create new columns, and even explore tables within a script. Hey, all right, we're back at the controls here, and first of all, we're gonna just go over the types of tables, what the table is, the difference between writable and non-writable table, and how to obtain each type, and the difference between table property and an actual table. All right, so first let's take a look at the table block. This is basically a table variable. Anything in the green block means it's writable. So if we open the table, and you notice controls here, add column, add row, this indicates right away that it's a writable table, means you can add stuff to it. Now, absence of these two buttons doesn't mean the table is not writable. There's certain cases where you can have writable table and it will not show you the controls here. Writable table means I can write to it, I can add columns, I can add rows, and I can do the same programmatically as well. Right, so how would you turn a writable table into a non-writable table? Right? So to operate with a table where you want to store something or add values to a table, you would need to make sure it's writable. However, if your original source is not writable, then you need to figure out how to make it writable. As an example, so let's use a list node block, like so, and let's grab everything under this HVC node. So I'll use it as a path, and so this is a non-writable table. It's an output of a block, and I can definitely not write to it, so here, cannot type into it. However, if I want to use this table, and supplement this with more data within my page, I need to make this a writable table. Now, one of the ways to do it is to simply use a state block, like so. So I'm going to use this green table as my target property, and I'm going to use this children table output as the value, and I just need to figure out the event on which to do the writing. If I just simply want a fresh table written every time there's a change, I simply could do this, right? So this would constantly write a table to this green writable block, and you know, it remains writable. However, there's a problem with that. Now, as soon as your original children list updates, it will overwrite your writable table. So anytime there's a change, anything you may have added to the table will get lost, will get overwritten with a fresh version of the children. To avoid that, there are various methods. It really depends what you're trying to do. For example, you may not need this write-on-change situation, so instead of using the table itself as a trigger to write it, you can just write it on some other event, for example on load, so it does it once but doesn't keep doing that, and there are several other ways of avoiding that. Okay, so that's how you turn a non-writable table, like an output of a block or a symbol, into a table you can actually deal with. Okay, so now it's time to take a look at the table operations. So there's add row block, there's remove rows block, and there's edit rows block. So let's take a look at them one by one. So add rows block. First and foremost, it needs a target, and a target has to be a writable table. This is a little bit unintuitive because you you're binding a target to the block, not the other way around. Nevertheless, it knows that your target is at the other end of this binding, right? So this table here. Next, you need to specify the column and the value that you want to add in your new row. Now, if we take a look at our table, right, so it contains a copy of the children table of this block, right? So let's say we want to add a row. There's the block, and in a column called name, we want to add a value called new VV, and then we probably want to add some more columns to our row. So we'll add another one, and let's say the path, we'll add the word unknown. Right? And you can keep adding columns. You can fill in all of them if you wish. I'll just keep it at 2. And then after that, all you do is just execute it. Right? And now if we look at our table, now it has the new row with the name new VV and a path called unknown. Now this, using this implies that you're dealing with a table where you know which columns it has, or at least which columns you need to write the value to. Because as you notice, this is not dynamic, right? So you cannot say, generate as many entries as you have columns in my target table. You kind of have to hard code column names into this, and they can be bound as well, but at the very least, the number of columns you have to manually specify in this block, right? So you cannot adjust them dynamically, saying if my table has 2 columns, then add 2. If my table has 4 columns, then add 4. So in order to deal with this dynamically, saying that add as many columns as exists in the table, this would have to be done inside a script, and we'll get to that part a little bit later. All right, so now let's take a look at remove rows. Now, idea is the same. You bind the target into the table property, right? So it's going to be affecting this table here, right? So we'll keep it down below so we can see. And here we need to specify a condition, right? So basically a filter expression based on which the rows will be removed. And for example, if I want to remove the row I have added here, the new VV, I can say name equals new VV, like so. And if I go ahead and invoke it, right, you see the row got removed. Right? So you can write the expression of any complexity in here. You can even embed small scripts in there using inline methods and basically remove rows based on various conditions. So pretty easy. Next candidate is edit rows. Again, it takes table as the target. And here, you, just like in the add row block, you need to specify which columns you're trying to modify, what value you're going to set, and a condition, just like in the remove rows block. For example, name equals VV1-11, right? And we're going to set column base, that's this column here, to the value new base, right? And maybe column invocable. And make sure I spell it right. Just paste in here. To the value true. Notice I'm not using quotes here. Now, when you type values into properties, no quotes are, actually, I made a mistake here. No quotes are required. There we go. So now if I execute, notice that my column base and column invocable was set to these values based on the conditions that were met, which is VV1-11. Right? Obviously, these can be bound from calculated sources, so they don't have to be hard typed. These can come from various other logic places. So that's quite all right. So are the column names. They don't have to be hard-coded. They can come from other places in your data flows. However, number of columns is hard-coded, meaning that programmatically you cannot increase the number of properties in here. You have to set them while you're editing the data flow. Once your application is running, you're no longer able to dynamically add or remove property sets from here. Okay, so that's all there is to it, to the three major table operations blocks. So that should be fairly easy to pick up. Let's take a quick look at a few others that may not be as commonly used, but are pretty useful nevertheless. Select rows block. Normally when you drag it out, it comes pre-bind because this is optimized to use with repeaters. So if you drop it on the data flow of a repeater itself, it'll automatically be bound to repeater's data and repeater's selected index, so you don't have to do it. However, you can bind it yourself. The input is any table that you want, and output is a row number or comma-separated row numbers to be returned. So if I, let's say 5, then my result would be row 5. See, right here, this is row 5. That's what select rows returned. I can also do something like this. Oops, too many 9s there. 5 and 9. There you go. So now I have 2 rows, now row 5, row 9. So that's quite useful when you're trying to return something based on selected index. There's also a block called table row cells. Now this one is a little bit different from edit rows, although it serves basically the same function. It takes a table as a target, and it does require a column, let's say name, and it requires a row. So this one doesn't take a condition. It takes a specific row number, so it can only deal with one row at a time. So let's say row 4. And it also returns a value to it, as well as can take it in. So I can add more property sets here. I can say also give me the path. So you can use it to fetch values from a specific row and then use them in your logic expressions. However, it will also allow you to modify them. So if I type back into this, so like so, right, it will actually go and write them to the table. So if we look at here, look, now it's 1-3A. Right, so this one has no invoke. It's basically write on change, which sometimes is useful. Sometimes it can get in the way of your logic. You just have to be mindful of that. So any change in the value will write it back to the table. Right, so that's it. These are all the table operation components I want to cover in this first portion of today's episode. After this, we'll get into script, and we'll take a look at what it takes to create a table or read a table in the script, and just see what else we can do with it. Before we wrap up this particular section, I also want to show you something quite useful, and basically it's a way of converting table to JSON and back, because often your data comes in a JSON, in the form of a JSON from REST API or other places, and it's quite useful to be able to make a table out of a JSON and then convert it back to JSON for various purposes. So if you search for JSON, so there's a block called JSON parser and table to JSON. So first, let's look at table to JSON. This is very self-explanatory. So if we go ahead and bind our table to the input, and what we get back is a standard JSON structure. It's an array of objects, right, where each object has a set of keys and values, which are columns within a row. Right? You can basically remove the row column. Remember, row column in any table, there's always a row column. That's added automatically, so it's not a column that may exist in the original table or data that you read in, but any table will have a row column, and if you don't want to have that column in your JSON, then you just enable the exclusion property here. So there's the table, quite simple. And JSON parser does exactly the reverse of that. So if you will just take this JSON output and back into the input of the JSON parser, and on the output you get a table again. See, it does have more options, right? So you are able to basically select kind of object at which to start parsing. You can set up flat or hierarchical filters. So if you're, for example, dealing with a REST API JSON response, that's set of nested objects, but only one of those nested objects is what you care about and what's going to yield you a table, then you can use the depth control, the selector, and filters here to basically parse one specific area of JSON into a table, ignoring the rest. All right, so that's it. So this wraps up our table operations blocks. This will cover most of your needs. I mean, and I know it does cover mine for the most part. Next, we're going to look into the script, the DGscript to be specific, which is basically a JavaScript that's been potty trained, so to say, to work in DGLux. And we'll see what it takes to control and deal with tables there in the script. Okay, we're back at it again. And this time we're looking at scripts. So we're starting again with our writable table that still has a copy of children from a node that we've done earlier. And next we're gonna drag out a script block. Now notice there are two. There's a JavaScript and script. Now script is what I refer to as DGscript. Again, it's basically JavaScript. However, it's somewhat dumbed down to work well within DGLux environment and reasonably disallow access to some of the areas where you can do heavy damage to what you're doing. JavaScript has none of those limitations. You can do pretty significant development in the JavaScript functionality-wise, but there are also some more work that you need to do to use it, right? Where you can't use some of the shortcuts made available to you in DGscript. So today we're focusing on tables and DGscript. So first of all, we need to pass the table into the script. For that, we add in a property to the script. We're going to make it a table type property, table data, and we're going to just call it data, like so. And we're going to bind the data into this, and I'm going to add another table property, call it result. We'll just use it as a property to hold our script output for various purposes. And I'm going to set it to auto run so we don't have to come back and execute it every time. Now I'm going to go ahead and jump into the script editor. It's not that scary. So again, I'm not a coder myself. However, I feel quite comfortable using the script. So first of all, how do we basically read in a table? We need to make it an object to deal with it at all in the script. So we're going to start with that. So notice that I don't have to reference this table at all because I know it as data property in my script. And I'm going to create an object based on this table. So we're going to call object myData. It's going to be equal to table get rows, right? And name of the property add .data. Oops, got my caps lock going there. Right, and I'm going to use a keyword object. This will create a JSON object, just like the one we saw after the usage of the table to JSON block, where a table becomes an array of objects, and each object has a set of key values for each row. If you don't use this keyword object, it reads it in slightly differently, where you're not going to get your keys for column names, all you're going to get is an array of arrays where outer array are rows and inner array are values within a row. So while you can use that as well, it's just less readable, and personally it's a little bit easier to deal with object type of with that type of object where each row is a set of key values rather than an array of values. Anyway, so that basically just made my data to be a JSON object. Next, if I want to read in my column names, I can do it in the following way. So I'm going to call variable calls table get columns dot data. So it's from the same table, and there are no keywords in there at all. So let's see what this outputs. So I'm just going to go ahead and return my data just so we can see what it looks like. So this is what my data looks like. So this is exactly the same object that you saw being output by table to JSON block, right? And if we take a look at calls, like so, right, this is simply array of objects where really you only care about the first one. So key name, value, column name. The rest are column types, widths, and other metadata that has to do with the way this table viewer shows up. It has absolutely no impact on on dealing with table programmatically. As a matter of fact, further, when you try to create a table from an object in the script, we'll take a look at that, it will accept a simple form of, we'll call it as calls, of simply an array of strings. Call 1, call 2, and on and on and on, right? So on. So you don't actually need an array of key values. It's enough to have an array of strings where each element is your column name. Right. So now let's move on. So how do we make a table from an object inside a script? Well, we'll use this result as a place to put our new table at, and the syntax is as follows. So table set, right? You use your target, which is add.result. This is the property where you're putting this table into, right? Then it requires array of rows, which is our my data object. Then it needs array of columns. So if I use calls, right, and go ahead and apply. Now this table is exact copy of my data table. If I use this other array that I created, call s calls, probably not gonna look like much, right? It's gonna have those two columns that I defined, right? Call 1, call 2, and then one empty one, and no rows, because remember in our object here we have no keys named call 1, calls 1, or calls 1, call 1, call 2, right? So if I output my data again, just so we can take a look, right, notice that I have no objects here where this is call 1 or call 2, right? The first key is the column name, right? So column name, right? None of these have the columns that I defined in this second array. However, if I do put names that do exist, for example, name, path, and something else, what do we have? I think base was one of the columns. Type is one of the columns, so maybe type. right? And so now you see that I do get a table, right? It has 3 columns, basically what I've defined in my scalls array. And from the object, that's my data, it shows the keys that match those column names, and I get my table, right? So this is how you read and create the table inside a script. Now, why would you do this? Well, here you can do things that would be more difficult to do without a script. You can iterate, for example. So for I in my data, right? And you can say that if I don't know, my data index I dot name equals to VV1 underscore 5. I'm going to set my data dot I dot type to be equal to superb. The results now, then there it is. So the column, so on the row where name is VV1-5, column type was set to the value superb. All right, so this is how you would iterate through an array and set something within the object based on something else. And you can create a new table, like in my case, right? So results are in completely separate table called result, right? And the data is not affected at all. So, however, it's kind of interesting because there's one keyword that you can add to this, or one parameter. So true, that would actually set the original table to this result as well. So if I go ahead and run this, and then I take a look at data, right? Notice nothing happens. However, if I bind my data right to the result, run this again, notice that now my original table was affected as well, because what I said basically in my script, right, if I kind of translate what I've just done, I just told it to not only set the property called result to this table, but also travel back up the binding if there is one, and set the original table that's bound to the result to this as well. So I modified the table that I read in initially. So I could have done it another way. So instead of using result, I could have set at data. Right? So now it's going to travel up the data binding back to my original table and set it to this value. So it's very useful, but it's also, if you're not aware of it, it could be dangerous, because if you want to make sure you're not modifying your source, well, this is a way to break that. So again, if we take a look, let's change the condition in the script. So let's set this maybe to VV1-3, so this guy here. So now keep in mind, we're looking at this table here. We're not looking at the script properties, right? So we're going to execute the script, right? You notice that this got set. So the script went back up the binding and actually affected the source. This only happens when you have the true keyword, parameter in the table set operator, right? So if you do not have that, there, and let's go ahead and change the conditions here, VV1-4. So if we apply this, notice that nothing happened to 1-4. However, if I open the data property over here, our 1-4 is set. Right? So original did not get affected. The result did. Well, in our case, data property got affected. There we go. So these are the basics of using tables within a DGScript. Okay, now we're going to look at the interesting situation where you have a repeater with multiple elements, and you need to be able to write back to the table that drives the repeater. So you need to be able to affect the table from inside the repeater that's driven by that very same table. Okay, so let's set up our context here. So I'm going to add, I'm going to start with a simple group, right? And let's maybe change the background so we can quickly tell it apart. I'm going to add a form element text input, like so. In my group, let me pretty it up a little bit. Just add some margins, and let me go ahead and change the text styling and background as well. I'm going to use a dark background with light text. That's good. I don't want a value. Placeholder will be just the word value. Good enough. Okay, I'm going to make this a symbol, convert to a symbol. We'll call it cell. Set that aside. Now let's build a repeater. So I'm going to insert a group, make this group vertical, go to repeater section, give it some data, and data we're using is a table we have from prior lessons. It just contains a list of VEVs and some basic data, just path and type. And the symbol, of course, we're going to use for this is the one we just built, cell, like so. There. Move this a little bit so we can see all of it. So, okay, so you have a symbol. So let's go ahead and edit one of the symbols. Edit symbol properties and add a label property. And we're going to bind it to the text input. Like so. And out here, we're going to grab the table, bind it to the label. There. So it's showing our name. But what I'm trying to do here is make this editable. Right, so I want the user to be actually able to type in here, which he already can because of the text input, but I want this new value to be written back to the original table. And it seems like a simple enough task, but might be tricky to set up at first glance. So let's think about this. I have a symbol that knows, well, it doesn't know much about the table right now. All it gets is just the label. So maybe first thing that we need to do is drop a map to table block to get the rest of the rows associated with this instance. All right, so now we get all three columns, but this is not a writable table. All right, so we can't really write to this. So that's not good enough. We can make this a writable table by creating a writable copy of this, but this wouldn't help us to write back to the source. So first thing that we need to do is add a table property. We'll just call it my data. I think the word data is actually already used in a repeater property, so it's not going to let you use the word data. So we'll call it my data. All right, go ahead and apply. And so here it shows up in my renderer. So what I'm going to do is I'm actually going to bind my original writable table that drives the repeater. At this point, it doesn't matter that it drives the repeater. It's a writable table. And I'm going to bind it to this my data property, right under the renderer here. So now when I go back in, and if I take a look at my properties, now if I open my data, notice that I don't have buttons here to add rows or columns. And this is one of those cases that I mentioned in the very beginning of the episode where your table may not show these buttons to add rows and columns, but it may still be a writable table. And this is one of those cases. If a writable table is bound to the repeater property, inside the symbol, it remains a writable table, even though visually it doesn't have any attributes of a writable table. So to this table, we can write. So what can we use to write to it? Well, in this case, will be edit rows block. Like so. So our target would be my data. That's the writable table. We need a condition, right? So condition is, well, it should be fairly simple. We know we have this row that corresponds to an element. We have the name and the path. Well, path is usually more unique. So let's use that for our condition. We just need to actually create an expression. I'm going to use a replace block. And I'm going to say that my condition is path equals path. And I'm going to replace this path portion. Again, this is not a required syntax. This is just personal preference of using, marking anything I want to replace in this way. And I'm going to replace this with the actual path. That's my expression. That goes into the condition. Right? And I'm going to be affecting the name column, right? Because that's what drives the text here. Right? I'm going to set it to the value of my text input. Right? So right back here. And the trigger to do that will be the onChange property of that very same text input. And there we go. So now my edit rows block will write to this my data table. It'll write to the row where path equals to this path, which happens to be whatever path is available to me in my map to table in the current row corresponding to this item that I'm editing. And it's going to execute on change of the text input, which is when the user types something in. So I'm going to go ahead and accept. There we go. And let's open up a table to see how it's affected by the repeater. So as a user, I can start typing and notice that values are being appended to the table right away on change. They don't fit very well, but they append. And if we look at the source table, the values are there because that's actually where they're getting written to. Right? So that is how you would have an individual instance of a symbol within the repeater write to a table outside of a repeater. So you pass a table as a property into the symbol, and then using a condition to pick a row that you're trying to affect, you use edit rows block to write to it. Hey, welcome back. Looks like you made it, and it's time to kick back and reflect on what you've learned. We've taken a look at table operations blocks. We now know how to add, remove, and edit rows in a table. We know how to tell apart writable and non-writable tables. We know how to manipulate a table within a script now, and we also know how to write to a table from inside the symbol in the repeater scenario. Right? This should give you enough of ammunition to go and build your own application with some interesting data manipulation. I'm Paul Sinenko. Until next time, please subscribe, set your notifications to let you know when the next episode comes out, and go build something.
Bye.